I was once an engineer. People consider me a fallen engineer, and now I'm a lawyer, and people consider me a recovering lawyer. You might wonder what the heck a lawyer is doing talking to you about Silicon Valley, and one of the things that I thought of in preparing this speech is that a lawyer is a little bit, in Silicon Valley, is a little bit like Forrest Gump in history. We're everywhere. It's just that you were looking at the other guy in the photo. And we are not much recognized, but the clients that we serve are very well known to you. I wanted to start, though, with a little bit of history, some of which you know about engineering and what influenced me as an engineer. I know you know the whole story of Hewlett and Packard and the oscillators and Fantasia. I know John Hennessy told you about this a few weeks ago. I just had to say it because every time I came to a double E class at Stanford, we started with the whole bit about Hewlett and Packard and the garage in Addison Street and all of that. And what I can tell you, though, is it was a very, made a very big impression on me and a very accurate representation of what goes on in startup companies even today. And I was influenced by a couple of people, some of whom you know. One is Jim Gibbons, I'll tell you about that, Doug Engelbart, Ted Hoff, and Dave Boston, all of whom had ties with Stanford. I want to tell you just quickly a little bit about how they influenced my life as an engineer. First, you know the story about Hewlett and Packard. Jim Gibbons, who's still here at this, over in the CIS lab, was a young professor when I was an undergraduate here, and he always taught at 8 a.m. He was a very busy guy. He had to, talk to Washington, D.C. in the morning and teach a class at 8, and then help his graduate students at 9, and then go off to help startup companies the rest of the day. And he was a very, very impressive guy who really managed his time. Still very active in Silicon Valley. He taught the introductory course to semiconductors, and he wrote the textbook. And I learned from talking to some of the students earlier that the textbook is, alas, out of date. But at the time, it was kind of cutting edge, the theory of transistors. And we were a week into the course and had studied the first chapter, learning all about transistor as amplifier. And he gave us a pop quiz. We walked into class one day, and he gave us a pop quiz. And he asked us to solve a circuit. I put a little circuit diagram down there in the slide. That wasn't the circuit. And we had to compute the current going through a resistor in the circuit. All we knew was that the model of a transistor was whatever the input is, the output is 100 times that. And so you could do this kind of recursive as a feedback loop. And you do this recursive calculation, and you get an absurd answer that was something like 4,087 amps. And we all wrote down, drew a little box around it in the cross-hatched engineering paper, that many amps. Except I wrote underneath, this answer must be wrong. And Jim Gibbons took all the blue books back and came back the next week and sort of tossed them on the table. So I'm very disappointed in the class. Everybody got the question wrong, and one student knew that the answer was wrong. I gave all of you a C except for the student who knew that the answer was wrong. I gave him a D. And I went up to Jim after class and I said, Jim, I'm the only one who knew it was wrong, right? And he said, right. I said, don't I get credit for that? And he said, no. I mean, you realized you were wrong, and what you should have done is step back, re-examine your assumptions. The one thing about this circuit you didn't know was what was inside that black box. You could have, by trial and error, figured out what the steady state current through that resistor was, and you would have known that the transistor was saturated, it wasn't an amplifier, it was a closed switch. We also would have known this if we had turned to chapter 2 of his book, but none of us had read ahead, and chapter 1 was this amplifier, and chapter 2 was this switch. But that is a lesson that I carry with me every day today. And I still see Jim regularly. He's on the board of Cisco Systems, which is a client of mine. I've played golf with him, and I remind him of this story almost every time I see him. And if you are a reader of the Stanford magazine, you will note the issue, it was just about a year ago, came out featuring teachers who changed our lives. And Jim was one of the 6 or 7 professors who was mentioned in that article. And I wish they'd interviewed me, because I would have told this story. They interviewed somebody else for it. But he had and still has a profound impact on my life, and refers me clients and startup companies, and some of them make it and some of them don't, but it's a lot of fun to stay in touch with Jim. And he helped me, he was actually my advisor during graduate school and helped me get a fellowship to pay for it and everything else. Another impact on my life was my first job was a summer job after I got my bachelor's degree at SRI International, which used to be Stanford Research Institute. And luckily, I had no clue of the importance in history, but I worked in a lab called the Augmentation Research Center, led by a fellow named Doug Engelbart, who happened to invent the mouse, Windows, a keypad that's really not used as an input device. And using what was called the ARPANET, the precursor of the internet. And it was a lot of fun. I mean, I interfaced a mouse to what today you would call a personal computer or a workstation. Had no clue of the importance that this would have on our lives in computing. It was all very far out research stuff that was only available at SRI. But he was a very, very, very charismatic fellow to have worked with. Then, during my graduate year, over in the lab in the basement of McCullough building next door, we were given the task of interfacing a video camera to a computer. The computer was an HP 2100, which had 32K of memory, and that was it, 32K total memory. My watch has more memory probably than that had in it. Our advisor was an adjunct professor named Ted Hoff, who also happened to be the chief technology officer at Intel Corporation. And we were busily trying to figure out how we could create a buffer memory to get all that video data into the computer fast enough. And we were soldering transistors together, and we were going to die. I mean, it would have been 10,000 years before we soldered enough transistors together to create a memory. And he walked over to us one day, and he reached into his pocket, and he dropped a whole bunch of chips on the desk and said, "Don't tell anyone where you got these. These are experimental chips at Intel. They're 1K DRAMs, and you can use them. It'll save you a lot of soldering." And in fact, we did, and we wired them all together, and suddenly we had a buffer memory. This was in '71. Intel went public in October of '71 at what in today's terms would be 2 cents a share, and today it's trading in the high 20s. And we had our nose so close to the bench and right up against the soldering iron that none of us thought to go out and buy Intel stock after finding out about these chips. And that, to me, is the single reason why Tom Byers needs to teach entrepreneurship at the engineering school, because you all need to recognize the import of what you do. Doug Engelbart never made any money on the mouse. You know, we never bought Intel stock. Ted Hoff certainly reaped some of the financial rewards by being an early employee there. But you know, we were so fascinated with the technology that we didn't understand the business implications.